Okay, so what I want to do real quick is just go over the idea of what a file is in regards to what we're going to be doing in the course. Because it's generally pretty important to understand how files work when it comes to dealing with Unix operating systems. So let's go ahead and swap over to the slides real quick and take a look. Alright, so again, this is just introduction to files, and one of the most defining traits of a Unix operating system is the idea that everything is a file. That is genuinely one of the most important aspects when it comes to dealing with Unix versus something like Windows, essentially. And it's one of the reasons a lot of people that deal with embedded devices and networking and servers and stuff really like using Unix is because of this paradigm right here. The fact that everything is a file means that when you interface with things, you can generally expect a pretty consistent interaction. Now, what do I mean by everything is a file? That ranges just from, your basic files that you're used to, like text files, source code, like C files, header files, stuff like that. The actual network connections, anything that has to deal with sending data out, reading data in, whether that be actual physical devices like USBs, your serial devices here, all of those are just files for Unix. They interface with the operating system like a file. And that even gets down to the input-output streams that we use when we're programming. So like if you're in C++ and you do CL and CN, those streams of data are actually just files in the operating system. That would be in the root folder, dev folder, and then the file of standard in. Same thing here, same path, except for now it's standard out. Those are present in the operating system. You can go find them in your file explorer, no problem. That's just how Unix works. So Unix uses file permissions all the time. So you have to be very aware of what these file permissions are and how they work. So they range from 000 to 777. Now technically, I'm only going to go over the 3 octal digit forms of the permissions. There are technically 4 digits, so a lot of the time you might see 0644 for file or 0777. You'll see these common because that 4th bit has other implications, and we're not going to cover that digit here because it's a bit beyond the scope of what we're covering. That's perfectly fine. If you go into the actual Linux man pages and all of that, you can find that data there. It is just beyond the scope of what we're doing, so I'm not going to add that into the mix. If this is already somewhat confusing, I would rather just focus on these 3 because they are by far the most important when it comes to dealing with this. So what those 3 deal with is your read, write, and execute, which are often seen as R, W, and X in certain applications, and there's also directory for a certain application. That's less important for the numeral versions though. So very often you'll see a chart like this, and that is going to be detailed in just one moment. So each file's permissions, which can be computed for the owner, group, and others. So let's say that you make a file. You are the owner of said file. In Unix, every user has a group, and they have multiple groups when you deal with system administration stuff. So often you can add users to specific groups if you want to give a group a wide branch of permissions, and instead of having to deal with, okay, give these 36 users a specific permission to access these files, you would add those users to a group and then give that group specific permissions to those files. That is getting into system administration stuff and is not the most relevant for this course. A lot of what we care about is going to be the owner, because you're just getting started with system application, Unix as a whole. So a lot of what we're focused here is going in the first category. And other, well, that's just everybody else in the system. Yeah, that's about that. This one will be very important in a few slides though. So each category is computed by the octal components of read, write, execute, and they all add up to the value of 7. So again, we have 0, 0, 0 through 7, 7, 7. The read is up to 4, write is 2, and execute is 1. So if I add 4, 2, and 1 together, I get 7. So if I compute these, I look at my owner, reads not set, write is, execute is not, so that adds up to 2. Nothing is set in group, that's 0. And then other has read and execute, but not write, so that adds up to 4 plus 1. That is 5. So you have file permissions of 205. Just never do that. That makes literally no sense whatsoever. There's no reason that you'd ever want to create a file where the owner cannot read it. No group can read, write, or execute, but everyone else that is not the owner of the file or a group that has anything to do with the file can read it and can execute it. This makes literally no sense. You would never do this unless you just were a system administrator with a vendetta, essentially. Now, our common file permissions that we're going to see is the ubiquitous 644 pattern. I've already written that a few times, and what this is just their general purpose. Allow anyone to read, but only the owner to write. So if we look at that, remember that's 4, that's 2, and this is 1. So read and write are both set for the owner. That's 6, and then both group and other only have read access. So that basically means that everyone on the system can read it because owner, group, and other all have read set, but only the owner of the file can make changes to the file. No one can execute it, and that's okay. This is like your text files or your source code, any document, stuff like that. You'll very, very frequently see 644. If you see 755, that is often an actual executable file. And that's basically the exact same thing as your 644 permissions, except for the execute bits, or the actual digits, are all set. So when you compile an application, so you had like a C file, you ran it through GCC, and it gave you the ever-present a.out. This would have 755 permissions. Everybody can technically execute it. If you wanted to have only the owner execute it, you could change it to have 744 permissions. That way the owner could read, write, and execute, but the group and other could not. I've seen some instances of 754 where the owner and anyone in the group pertaining to the file could execute it, but no one else could. I've seen that, and that one's not as common. A lot of people just go with 755 and call it a day. It just depends on what how tight of security you want to have is. But GCC as a whole generally does 755 by default, so you'll see it very, very frequently. And then mine and a lot of security experts, system administrators, and anybody that has an ounce of sanity and a shred of dignity hates is the 777 permissions. And what this means is that anybody can do anything. This should scream red flags right off the bat. Again, having 7 for the owner, that makes perfect sense. If you're in a specific group, sure, that might make sense depending on what the group is, what those files are, what the project is, etc., etc. That just depends on the administration of that whole project as a whole. This should never ever happen. There is no world you should give every single user that interacts with the system, even if they are SSH'd in like a remote user, that just has complete access to read, write, and execute any file, this actually does lead to genuine problems and can lead to really, really bad, I don't know if I want to say malware, but it's bad actors doing what they do best and making other people's day worse. Do not do this. This is bad. Just don't. Especially in a professional environment. If you're doing it on your own local device, sure. It is very often used as a hacky workaround whenever I don't have access to my file, my program can't write to my file, or some other reason. You need to sit down, look at the permissions of the file, and figure out what you are doing wrong before you just say, I'm going to give it 7/7 permissions because I feel like I've hit a brick wall and things just aren't working. I see this very frequently in this class. I've seen it frequently in another course that dealt with distributed servers and client programming and whatnot, where you actually had all of your files off-site essentially. And so you had to remote into a server to actually execute your files. And be like, oh, well, my teammates, they don't have permission to read my files. So I just gave everything 7/7, and now that fixed everything. That didn't fix things. That's like just saying, oh, the lock on my door broke, so I got rid of my door. That's not a solution. Don't do that. Don't do this. I cannot stress it enough. Please do not do 7/7 files. It is gut-wrenching to see this. No. Anyway, moving on. When you want to actually change anything with the permissions of your files, the chmod command is your absolute best friend. So there are two links here. One is an actual official man page, and then one is an online source that I like quite a lot that lets you kind of see a more, I guess, abbreviated and I guess user-friendly version of this command's actual permissions, like what's going on there. So as an example of it, this is removing a compiled file to executable permissions. So let's say that I just compiled this a.out by running some source code through GCC. And it's like, okay, for whatever reason, maybe I want to say, oh, I don't want anyone to execute this right now. I'll do chmod -x. That essentially minus basically means removes the executable permissions here. And so if I try and run a.out, you'll see permission denied. If I wanted to add the actual executable permissions back, I would do chmod +x to that file, and that would add the executable settings. And if you want to do chmod with the actual numbers like 644.755, you can do that too. Again, you can find all that information in these links here. They're genuinely very good resources. A lot of systems programming deals with reading Linux man pages and other online documentation for how these things work. And they're very, very lengthy. It is genuinely just core documentation, which you may or may not like. And then we also have the ability to view the actual permissions of files, and you will see, if you ever watch me do anything in terminals or development, you will see me run ls a million billion times. I use this command probably more than almost any other command available on Linux. And all it does, it just lets you see, if you just run ls by itself, it just shows you the files that are currently in a directory. But if you use some of the actual flags and whatnot, like -l or -g, it lets you see more actual details about those actual files. Stat does the same thing as well. As an example, here's an example on the right, ls, and on the left we have stat. So we'll look at the ls one. The ls -go is basically the same thing as ls -l that I frequently run. And all it is kind of abbreviated. It doesn't show the owner or the group or whatnot, so it just makes the screenshot here a little bit easier to put in a PowerPoint essentially. So I can see all of the files in my current directory, all the CPP files, header files. I can tell that this is a directory because the D is right there. A.out, that is an executable because I can see I have the executable permissions set right there. And then everything else has, again, this is the owner. Here, these three are the owner. Here's the group. And then here is the other. So read write, that's 6. Read is 4. Read is 4. That is 644, which adds up to the stat command I ran here, which is a little bit more hideous as a whole, but it shows the actual numeric results for the permissions. So I can tell that this one, this A.out should be 755 because I have read write X, so RWX here, RX, and then RX at 755. And you might notice over here, again, this is why I said that this one's a bit odd. Its numeric one is 755, and the letter is all the same as 755, except for it adds the directory one as well. So you can view them just fine by using the commands. Again, I use ls-l. If you're on Ubuntu, or I think Debian might add it too, you'll see ll very frequently. It's an alias for ls-l essentially. And you see those all the time. They're generally fantastic to just kind of get an idea about where you are in your file system, what the permissions of your files are, and it gives you a lot of information so you can see at a glance of what you're dealing with essentially. So that's basically just a brief introduction to files in Unix, kind of how the actual permissions work, and then a few commands on manipulating and viewing those actual file permissions, because they're very, very important to have a core understanding of how a Unix system works essentially. Having a good familiarity with the file structure, whether it be your file system management, understanding directories and whatnot, and then all the permissions for the files. Having a core understanding of all of that it should be important for anyone doing development, but especially if you're on a Unix system. It's very, very important. It's important if you're on a Windows system or any system at all. It should be important. But in Unix, since everything is a file, you kind of need to have a clear understanding of that concept and of all the ideas about permissions and whatnot. It goes a really, really long way, especially if you're dealing with system administration stuff, server access, anything doing remote desktoping and whatnot. It's just quintessential. Like, it should just be like standard entry to, you can use a Unix system if you understand these aspects. And I'm not going to say everybody should just be intrinsically able to understand this. Some of it can be very, very confusing at times, and I know I harped on the 7.7 stuff, but it is dangerous, and you do see people in professional environments do that. So it's good to understand why you shouldn't do that, instead of just being told, hey, don't do this because I said so. There's a very good reason why you shouldn't do that. So I do hope that this video helped elaborate on all those things. I hope it's been helpful, and I hope you learned something. So that's all I got. I'll see you in the next video.